All right, you guys. Welcome to track one, the first session. We are kicking it off very strong with Dave Hefner, one of our most popular speakers. And for those of you who don't know Dave, which is maybe like one or two of you in the room, he is the writer of Elemental Selenium, which is a free once weekly Selenium newsletter. If you guys don't subscribe to it already, you definitely should. It's read by thousands of testers. Woo! And also, in reading his bio, I learned that he's the creator and maintainer of the internet. Did you guys know that? Actually, I know, him and Al Gore. So it's actually an app that he created that's really helpful for you guys on GitHub so that you can do your automated testing against it like a practice app, which is awesome, so you should check that out. He's also the author of the Selenium Guidebook, and he's helped a ton of companies implement automated testing. So really happy to have him here. He's also an active member of the Selenium project. He's talked at numerous conferences, and he is here today to bury Flaky Tests. So welcome, Dave.
Thank you. So I like to start with a definition about generally what I like to talk about. And Flaky Tests, I don't think are too misunderstood. I think everyone has experienced them and has probably a similar definition. I define it as an automated check that has non-deterministic results. And you might not be able to see, it looks a little bit washed out, but used in a sentence, the test failed but passed when it ran again. It's a flaky test. And so synonyms for this are known roughly as transient test failures. I define it as a bad thing and also a very bad thing. And I say that because it's to me, an endemic problem that we have in the industry that we have come to accept as normal, as just par for the course of part of our job. And if you just take a scan of even just this conference, there's at least a half dozen talks where the core focus is on something to do with flaky tests and techniques used to mitigate them. And it just seems like it's a catch-all title that is used and which correlates with dismissive behavior. Oh, that build didn't pass. The test ran, but they didn't pass. Ah, they're flaky. There's some flaky tests in there. Moving on. And the common thing people say is this erodes trust in your automated testing practice. And this leads to so many bad things. Obviously, it creates this huge expense, right? Time to debug and fix these issues. Just the cognitive load and the stress of like, I just don't really trust these things. And then there's just the time just to rerun these tests. Like how just the pure fact that you rerun these tests, there's an expense to doing that. And so the bigger issue really, how it impacts the business is it creates these opportunities where production defects can just float through your tests because you just don't have this trust in what the tests are telling you. And so I think that the most dangerous part about all of that, though, is that it's just normal. We accept it. And that's really something that I've thought about for quite a long time, several years actually. And so more recently, just to prep for this talk, what I started to do is look to what's being talked about within the ecosystem at conferences and blog posts more recently, just to make sure that we have a kind of an even smattering of reference material to work with. So I looked at the Google testing blog, which has how Google mitigates their flaky tests. And they have a follow-up post to this, which was really interesting about like a data scientific deep dive into trying to understand what's going on and try to fix it. That's just more interesting for kind of after reading, but the salient points for this discussion is that 1.5% of all of their test runs report a flaky result. And when they zoom into that, 16% of their tests have some level of flakiness within that continuous test run that's reporting flakiness. So that's 1 in 7 tests created by world-class engineers that have flakiness for one reason or another. And also, reruns were cited, rerunning a test after it's failed, were cited as common practice, even though in the article they say, we know it's not great, but is what we do. So this is Google, right? So this is kind of the one way to look at it is a benchmark of how a really great engineering company does this, so 1.5%. I've been talking to a couple of companies, a couple of people who across a different range size of companies and different maturity practices. Like anecdotally, it seems like anywhere between 15 to 25% is kind of more the norm that people see for retry test failures, and that's just what they all do. So I see this as that's kind of the range. That's kind of the spectrum that we're looking at. And so if we jump then from this article back a little bit to GTAC 2015, Alistair Scott of Watermelon fame, he gave a talk called Your Tests Aren't Flaky. And so a few points here, he cites that a rerun culture is toxic. So that's just, he does sometimes speak in hyperbole, but I think that there's a lot of truth here, that a rerun culture creates some really dangerous habits. And also, flaky tests that caught a bug were missed. So he has an interesting anecdote he talks about where they had about 500 tests at WordPress where he works. And they run them all the time. And they feel really good about the code quality that's in the tests. And they wanted to cut a release for production. And so they ran all the tests. And they broke them up into groups. So there's about 50 groups so that they can parallelize them appropriately with the hardware they had. And something like 5 of the tests out of the groups failed. And they were like, that's strange. So they reran just those 5 groups, and then only a couple of groups failed. And they said, that's strange. And they reran until there was just everything passing. And then they said, cool, everything's green now. Let's roll on to production. And then they started to see this error that affected 10% of their users. There was this obscure caching bug. And then if you correlate 10% of users had this issue, 10% of their tests failed, and then they just reran them and they passed. It's like, oh, the tests were actually telling them something, but they were like, oh, but that flaky test, they ran fine the second time. And so instead, what he then worked on after that was making the app more testable, as opposed to just trying to get around this rerunning test. So that what they did is a whole lot of work around trying to make it so they don't blindly rerun tests. And then anytime there was flakiness, they'd use that as insights to work on making their app more testable. And so his big thing is your tests aren't flaky, your application is. And so if you make your application more testable, then everything's easier. And so many people, everyone in this room has probably experienced your app just not being built for testability, even just in the screens that you have to test, not having good locators. But the talk's an interesting one because of some of the techniques that they applied and some of the architectural decisions they made, and how much more reliable everything was after that fact. So that's one example. Another one came out of Selenium Conf London in 2016. So Dave Cadwalder at the time was working at Walmart Labs, and he had this great talk on big data makes the flake go away. And there's a few things that are interesting. So he has this acknowledgement in the talk that there's a stigma with flaky tests. So he wants to take flake back. And so hashtag hooray for flake. And so he's trying to make it a positive thing that trying to say is telling us something, we should look into this. And then the really interesting point I thought was he then demonstrated how at Walmart they used this open source app that they created called Bloop to track the stats of test runs at volume, and then use standard deviation to look both at between each test and between each test in each browser, and kind of have an at-a-glance dashboard so they could spot which tests were flaky and which ones were actually pretty okay. It wasn't precise, but it was an interesting dashboard that was enabled them to have a heading of where to look. So when developers see, the test ran here, and here's just a whole bunch of data, you can imagine the volume of tests. They wanted an at-a-glance way to know, okay, here are tests that are problematic over time. And so here's where I need to go and have attention. So an at-a-glance way to spot tests. And also, the tool I mentioned is part of this open source org that they formed called the Test Armada, which is the first time I've heard of it. And I don't know many people that have heard of it. Anyone here heard of the Test Armada? A few people, okay. Yeah, so they have the open source Bloop. They have other tooling. Their big thing is trying to make a framework agnostic and language agnostic set of tooling to help the industry just standardize around how to execute tests in parallel and how to have good reporting. And so I think that's pretty cool. So it's nice to see instead of just saying, make your app more testable, or use big data, they're like, no, use big data, here's some tools, and here's some ways to standardize around the document, around a standard of some kind. And even last year here at SauceCon, Craig Schwartzwald, who's also here in the audience, donned the stage and talked about say goodbye to the F word, flaky no more. And it's a great talk because it just basically is very straightforward. You can avoid flaky tests with good test design practices, and then he steps through those design practices. Like, that's all there is to say. Everyone should watch the talk. It's like the practices are there. It's in Java, but if you're not Java, then figure out how to port them for your own needs. And for his use case, it works well, and it might be useful for your use case too. And then last year, SlameConf Berlin, Richard Bradshaw gave a very poignant and pointed discussion on your tests aren't flaky, you are. And I quite like this talk. So the punchline for his is flakiness is actually something that we designed into our tests. We created this problem. And he's fun to talk with in general about testing because he actually thinks we fundamentally, hey Richard, fundamentally we don't as an industry understand testing, and I think that I agree with him, especially since flakiness is such this prolific problem that we have. And so I also think it's a great point was flakiness is an opportunity to improve, and you shouldn't ignore it. Just like the example with Alistair Scott and how they had their tests telling them something that was actually a production bug, but they just ignored it, reran their tests, and they moved on. That was an opportunity for them to understand something about their app that they didn't know before. And so there's another bit that he has, which he has coined a new acronym called SACRED. And he also had some really good questions to ask. I won't go into the acronym. I think you should really watch the talk in order for it to really do it justice. But it's a good mental model for how to think about how to architect your automation. And then some good questions are you testing at the right layer? Can we improve testability of the app? And should this test even be automated? This check, should it exist? So some additional perspective. And then more recently, Katrina Collocate did a Twitter poll saying, I'm seeing competitors to Selenium emerging, what do you think? And people are either saying, I'm moving to Test Cafe or Cypress or some other tool, or I'm sticking with Selenium. And so this is a great write-up from Michael Krzyzanowski, and where he kind of summarized so much of the thoughts I have around this topic, around tool selection and what's right for the team, and how do you design tests, and how tests should really be treated like application code with the same care. And his punchline here is, if you do not treat test automation well, why are you expecting miracles? So people who might be manual testers learning to write automation, just throwing something together just to get testing done, but it's a practice that really needs to be treated with exceptional care, I think. And so it's like no surprise that people either think Selenium is a terrible tool and has this reputation for being slow and brittle. But there's practices you can do to mitigate those issues. And so I think this blog post is an interesting take to kind of round out the perspective. And so if you think about some different perspectives, there are different ways to approach how we work with test code. And some of them people might already be doing, some of them are new. And Angie Jones recently for Tech Beacon had this great blog post around 6 reasons to collocate your app and automation code together for testing. And I've never actually in practice done this, but I've always had this hunch like this would probably be way better in a lot of ways, because you have access to so much more information. You could probably hook directly into how the view gets rendered, so you can avoid having to always try to update locators. There's all these different benefits potentially to doing it. And her blog post just totally sold me on the idea. I think it's an interesting blog post that everyone I think should consider. There's also Greg Seipel had a recent blog post on the Sauce blog for model-based testing, talking about just kind of what it is, how they're using it at Econet, and linked to some great talks like from Spotify and other folks on basically how it's being used in practice. But it's effectively generative testing. That's a bit more abstracted from the day-to-day stuff that we're used to, where it's very specific. You just basically can map out the thing that you want, and then the test cases get generated as a result, as a byproduct, and it's hooked into the app code. And it's a phenomenally interesting thing, so it's a different approach. And I think that, and Greg seems pretty bullish on it. He's right here. So talk to Greg about model-based testing if you get a chance. And there's also things happening, like Applitools recently announced a whole new class of technology where they're taking their AI-based tooling for visual checks, and they're going to branch out into other areas and potentially fundamentally change how we consider testing. And in that same breath, there's also AI, like a lot of companies are popping up around AI for software testing, which I'll put under the grouping of magic, but it's happening. And so this abstract from Jason Arbond, who was co-author on How Google Tests Software, was probably the most the best introductory kind of more down-to-earth approach to talking about the different options for AI, deep learning, machine learning, and the applications for software testing. I mean, he has his own company around it, so it's definitely something he wrote for that benefit, but it has a lot of good insight in there that could be helpful for kind of getting context. But I think the future is cool. I think that there's these tectonic plates shifting in how we do the work that we do. But we still have existing Selenium test code that we rely on today. And so that's great that we haven't solved this really hard problem with Flaky Tests, but we're going to build this super smart, way harder to solve problem that's going to come and fix that for us. I'm like, that's probably not going to happen anytime really soon. So I think that there's things we can do right now that can actually help. And so I have this kind of mental model that I try to apply when I try to diagnose flaky tests. So I have this test matrix. So you take an individual test and you plot it on this 2x2. And on one axis you have you just want to look at how has the test performed. So if you just think simply, look at the pass percentage, right? Because a test has 3 states, right? It's either pass, fail, or error. So just look at the pass. Let's just start there. Let's keep this as simple as possible. And on the bottom, you just say, what's the score of the code in the actual test? Is the test doing good things? And so, just to keep it simple, you say, just look at, does it have good locators? Or are they going to be brittle locators that are likely to break? And what kind of synchronization strategies are you using? And there's a lot to unpack there, but let's just keep it at that. And so when you plot it out like this, and if you think about something that is performing well, has good consistent passing results, and has a good code score, that's a reliable test. But on the inverse, if it has a low code score and it is passing, so it's performing well, but it has some terrible things in the test code itself, it's likely to fail. This is a predictor of something that hasn't broken yet, but has a high potential to break. And then on the flip side, if you go to the bottom right, you say, oh, well, the test is performing poorly, but it has a high code score. So the test code's fine, but the performance is suspect. Well, maybe it has nothing to do with the test code, and you should look elsewhere. It could be a network issue, application issue, environment issue, latency. There's so many things, test data management. But this helps at least point you in the right direction. And then if you have poor performance in terms of it isn't passing that well, and they have a low code score, it's just broken. So to me, flaky is too abstract of a term. So when something fails, it's like, oh, it's flaky. You just want to dismiss it because it's too high level. And I'm not even advocating for fixing the root cause or even identifying it. And that's fine if you have the time. But I'm just advocating for zooming in just a little bit more and understanding it, put things in the right bucket to understand what's actually happening, so you can start to pay attention to the signals that your tests are telling you. And so I think that we can remove flaky from our vernacular. And if we do, I think we can remove bad habits that are attached to it. So I have this entire talk that is dedicated to this idea of scoring in a quantitative way your Selenium test code, both for maintainability and reliability. And so this is just the slide from the locators, which locators make up about 50% of the grading rubric score. So if you're interested in kind of understanding more about how I think about this stuff in a quantitative way, feel free to check that talk out. And so I think that available tooling doesn't cater to people with existing Selenium code, right? It's always about oh, come use our tool so you can author your tests and they'll be reliable. But nobody's tackled the problem of Well, you already have existing Selenium test code, and we have all of these practices. I mean, we have best practices all around us, but we're not all using them, or we're trying to, right? There's so many to learn. We're tripping over them. We have so many. And so instead, what I think is we need to codify all of these practices, at least the ones that matter, into an automated feedback loop or a set of them to make the path to successful automated testing simpler for everyone, so we can rise all the boats. And so we need better tooling. We need tooling that's effectively, if we're going to treat test code the same as application code with the same care, then we need similar tooling to do it. And we just don't have it. And so the way I think about this is, I think about our test code with Selenium in two ways. I think it's either, you think about it in flight, like when the test code is running, there's data that you can get out of the Selenium tests. And then there's also test code at rest. So when the tests aren't even running, there's things that you can glean from it. So what that looks like in practice, there's things like the abstract event listener, and I'll spend a little time talking about that in a minute. There's also tapping the underlying wire protocol for Selenium. And then there's parsing the logs, the artifacts that come after the test is run. And then test code at rest is just one thing. It's static code analysis. And so with all of this, to paint that full picture for the 2x2 grid, you still need the test run data. You need the metadata of how the test performed. And so things like the test name, the pass, did it pass or did it fail? And right, for everyone here that uses Sauce Labs, it's like you have this information available in Sauce if you send it to Sauce. And not everyone does. Not everyone does consistently. Even, if it's not baked into your framework, it's something someone has to do. It's like you can get inconsistent results across your team. And if that happens, then it's a bit tricky because then you don't get consistent data. So that's just something to just encourage everyone, if you're running tests in Sauce and you're interested in doing something like what I'm advocating for, just make sure that you send that metadata up, and then you can start to really get a lot more insights out of your test runs. So just remember, data, paint the picture. You need both axes to do this task. But let me talk about the abstract event listener. So the abstract event listener is, I think, the most interesting advanced feature that the tool has that is the least known and probably least documented piece of functionality. But basically, within Selenium, you have, and it's just Ruby code because it's more concise than the Java code, so apologies if you're not a Rubyist. But you have access to the before and after of all of the primitive functions that Selenium does. So whenever you find an element, whenever you navigate to a URL, whenever you click something, whenever you execute JavaScript, you can grab information from before and after. Some people use it for logging, but you also have, in this case, access to things like the locator that's being used, the DOM, if you get the page source and do some things with that. You could start to build really interesting tooling that could help for debugging. There's so many different things you could do with it. And so the best documentation I found was basically this snippet in code comments. But the approach to use it is pretty straightforward, at least in Ruby. I think it's very similar in other languages, though. You have to subclass the abstract event listener, and then you just pass it in when you create an instance of Selenium as just an extra parameter. And so you basically, in this example, they're creating a listener on navigating to URLs, and they're just logging that. And that's it. So that's a really simplistic example. One example I've done was for additional debugging, where I wanted to output in the DOM little growl notifications every time an action was fired with Selenium. And what that looks like is this. So in this example, it's just outputting, I navigated to a URL, I found this element. It's just, so when a test runs, I have this additional debugging output of everything that's happening, when it's happening. And I don't have to correlate between looking at the logs and looking at the test and looking at screenshots. It's just all stitched together. And this is all a trivial amount of code using the abstract event listener. And since it's not well documented, I figure I'd go ahead and point you in the right direction. C#, Java, Python, Ruby, these are the links to the classes in the code. JavaScript is not implemented, and there's no plans to implement it. But if you wanted to use a proxy object, a JavaScript proxy object, you could do that and actually grab the events out of that you want. That gets you essentially the same thing. And so The internet's kind of light on some blog posts about implementing this, and I think I might help remedy that eventually, unless anyone here is feeling adventurous. And so I think I want to talk about this just because I haven't really seen this in a conference talk, and I think that there's a lot of opportunity around this space around flakiness and other tools, better debugging. There's so much power that you can do, and it's quick setup. That you get this information for free. You don't have to kludge anything together. You don't have to parse files. You don't have to do any of the heavy lifting. So you should do it. You should, like, if you're feeling bent on trying to make your practice better, make your tests better. And I think that, and if you do, and it's something that would be beneficial for everybody, then open source it. Like, I think there's a lot of opportunity to create sister projects from Selenium that would be helpful for everybody. So static code analysis, though, is the one that I am particularly interested in. So also known as linting. And so a linter, or lint, refers to tools that analyze source code to flag programming errors, bugs, and stylistic errors or suspicious constructs. We have these for application development all the time. And we have these tools that exist for specific programming languages. But what we don't have is a tool that does this for Selenium. And Selenium is interesting because there's 5 officially supported programming languages. Linters are usually just for one language. And so to make a linter for Selenium, you'd have to make a linter that works for 5 languages. So you'd be crazy to do that. But I think it's the most useful in terms of direct action because you can address anti-patterns where the code is. Like, you could say, I found that one locator that is suspect. You don't even have to run the tests to find it. You just have it, just point at your code, run it, it spiders through, finds all the offenses, and you could start, so your existing test code you could assess at scale pretty easily, is the test code any good or not? And so you could identify locators, weight strategies, all of these things. That's why I think it's so powerful, because it points to the exact line of code, and it gives you a message about what the issue is and why. And this whole idea, for everything I'm talking about, I think really came about from a big client engagement I had where I was hired to review a lot of test code. I came in for 2 weeks, and this client had 200 or so dev teams, each with their own test code repositories, and on average, the size of page objects I was seeing were on the order of 3,000 lines long. And so I managed to make it through effectively one test code repository. And from that, I realized that's not scalable. And so I created a training with the help of the person I was working with at this engagement, and we put together this interesting rubric, which now the world has seen, if you see that talk from earlier. And we delivered this training to development teams. And we created this simplistic test sheet that they could grade to make sure that they understood how the rubric worked, and everyone got the same score. And they said, cool, now you go and look at your own test code and score it. And they did, and we tallied up the results. And I was kind of, through observation, I'm like, I'm not sure if everyone was honest, and and I'm also not sure if they caught everything, because it seems like it'd be a very error-prone thing to do. And it's not something everyone would want to do all the time. It's something that absolutely should be done by a computer. And so I started working on one, and so I've built an initial prototype that I'm starting to kick the tires with. And this is just a screenshot of the output. But I'm looking for basically everything that is in that grading rubric talk around locators and weight strategies. Like, I'm not looking at like lines of code and giving infractions for maintainability. I'm looking specifically at anti-patterns that cause test instability. So that's what this is doing. And it's very nascent, and I'm not exactly sure what I'm doing with it yet. But if you're interested in kind of seeing what the functional prototype is, talking more about this stuff, I'd love to talk to you about it. But it works on every language, and so it just doesn't work for every framework in every language. Sorry, Greg. But that's something that could easily happen, and so that's just, I think, the beginnings of better tooling, which is what we sorely need, I think, to move forward as an industry while we wait for AI to show up for us. I tried not to roll my eyes. Did I roll my eyes when I said that? wait for AI to show up. Okay, sorry. So basically, I think if we just zoom in a little bit, just a little bit, from when we talk about flaky tests, say, oh, hold on, let's just zoom in, let's understand a little bit more about what's going on. I think that we can understand a whole lot more about what's actually happening in our tests and what's actually happening in our app, which is the point of having the test to begin with. And then we can just remove flaky from our vocabulary by doing that. We could kill it dead, because we can just say, we could move away from it. We can move past it. We can evolve as an industry to think about these things in a more mature way. And then I think that we need to truly treat test code like app code by offering equivalent tooling to what we have in application code. And so if you're interested in building tooling like this, if you're interested in using tooling like this, like I'm all ears. This is my jam. So if you're interested, for people on the internet who aren't here at the conference, feel free to contact me at that URL. And anyone that's here at the conference, feel free to come chat. So how much time do we have for questions? We got 5 minutes for questions. So questions, anyone? Questions?
So, the event handlers? Oh.
Do we have a microphone? Do you want to do that? Up here. Up front. Sorry. Un momento. Thanks for your patience.
So with the event handlers, how do you handle like the fluent wait? Because those logs get pretty special.
Oh, so you're saying
after a
like
short time?
client-side waits that are effectively wouldn't show up in that. I mean, in abstract event listener, you effectively wouldn't. I guess it would just be triggering like a new find element, or
Or you turn it off until like the last iteration when you've actually found what you wanted. Caching.
I think so there's no. I think there's things to figure out in that sense, and I don't fully even know what there's like really no limit to what you could do, but there are cases where it becomes more challenging, where you have client-side things versus the server-side things. Because abstract event listener is tough. Like that's not what I don't focus on that so much.
But they're awesome.
They're awesome, but for what I'm doing, it's not as useful because there's some things I just can't get insights out of. But for tooling to make better debugging decisions and like to make better tooling that could, I don't know, there's so much you could do. But as far as fluent weights, I'd say as a consultant, I have to say it depends. So sorry. Any other questions? Got one in the back left.
There are some cases you write code and the tests are working fine, and somebody else like pushes the code, now test starts breaking. How do you like counteract that kind of situations?
You say push code, you mean they push application code changes?
Application code, and then the tests which actually worked previously, they start breaking.
Like so if the locator's changed in the
Yes.
UI or something. Well, in this case, this specifically wouldn't help. There's actually a whole corpus of tooling that I think needs to exist, and the linter is just one component of it. There needs to be something akin to effectively what Testim has, which it's something that could be intelligent enough to figure out what the locator changed. So what is the new locator? And with Angie Jones' Tech Beacon blog, that was the biggest advantage to me and even model-based testing of being aware of what's actually getting rendered in the view. So if something like that changes, the test is able to adapt. And so I think that we need better tooling because fundamentally that hasn't ever changed since Selenium came out. It's still on the linchpin of you need to figure out the locator, put it in the test, and if it changes, you have to update it. Like that to me is a fundamental flaw with the whole process, given that things will change. Unless you have locators that are unique, descriptive, and unlikely to change, which are like exquisite and hard to find, and require like a really mature discipline. So, yeah. Well, you got one up here.
Sorry. There you go.
So I have to confess, I have never used the, the event listener, but in your experience, if we start putting the event listener for all the actions, will that impact the performance of the execution of the scripts?
That's a great question. Will it impact performance? It depends on what you're doing. So if you're writing it to a database to do something with it, or if you're doing something that's like fundamentally off the machine or has expensive I/O locally, yes, it could. So in one of the talks I linked to, the guy from Walmart Labs, Dave Cadwallader, the way that they got around that potential latency was when they would fire off commands for their monitoring stuff, they would send it UDP instead of TCP. So there would be no, so it essentially just, it would cut out a lot of buffer in terms of like, they didn't care if they lost the packets necessarily. And so other than that, you'd have to build some sort of asynchronous handler where you would just say fire and forget and hope that it just gets processed in the background. So these are things you'd have to account for. And so debugging generally costs more for anything when you enable a debug mode on something. So I would say if you build something like that, then maybe use it more sparingly. Unless you know that the test has been flagged as problematic, then you could turn it on for future runs for the next 50 runs or something, and just see if you could spot where the issue is. Now that does beg the question, like once you start measuring it, doesn't it change? And like, so it's an interesting question, and I think these are problems that we would need to solve. But we got to start somewhere. So yeah.
Thank you.
So I think we're on time. Okay, great. Thanks everybody.